Okay, so in the lecture, we just saw kind of all of the important points that happen in the filter optimization. So what happens when we hit tune GIF? So there's a bunch of imaging kind of aberrations that get minimized or corrected, and spectral aberrations. So I'm going to walk through that quickly actually on the filter now. So I'm looking at just a flat field illumination on the camera. I'm actually in service mode, so you're going to see some palettes here that you don't have access to, but it's just for illustration purposes. So I'm going to go ahead and insert the mask. So this is the 81 hole mask, and it's just a very well-defined pattern kind of that we know how it should look on the filter camera. So it's good for our imaging calibrations. So the first thing that we need to do is an image shift. So the mask should be centered on the camera. So we have deflectors where we can move in X and shift in Y. So I just moved that guy wrong. Okay, so let's put it back. After the image shift, we need to correct the magnification. So that's done with some multipole lenses. So you can see if I change this lens, it changes the magnification or the projected size of the mask pattern. Next, we interested in correcting an aberration or an artifact called chromaticity. So if the filter is perfect or behaving perfectly, all of the different kind of energy losses, so all of the inelastic scattered electrons from a particular point in our object should form, kind of come to a focus at the same point in the image. So if that's not the case, we have chromatic blurring, which is something that we want to avoid. So the way that we can use the mask to kind of help us correct for chromatic blurring or chromaticity is to use the drift tube to actually kind of offset by some amount of EV, and then do what we call a wobble. So essentially we can form two images or kind of different energies. So at the moment I'm actually the chromatic kind of blurring is very minimal because the chromaticity is well corrected. So what we're actually looking at is two kind of images that are kind of 25 EV separated in energy loss, but with no aberration. So I'm actually going to introduce some chromaticity and show you the effect. So if the chromaticity is bad, you can see that's the effect. So you can imagine like how that would look in an image. You'd have your features just kind of smeared out over the camera. It's very kind of clear here because we have this mask pattern. Okay, so that's chromaticity. The final imaging aberration is just distortion. So distortion will just look, it'll be some non-squareness of the mask. So I can kind of misalign one of the distortion lenses, and you see that I introduce some curvature there in the mask. That's something that we want to avoid. So we want to always have that mask square. So that's all of the imaging corrections that we apply. So anything done with the mask. So the spectral correction is that property that the aberration that we learned about that's called isochromaticity. And isochromaticity is really just recalled from the lecture. It's the measure of how well in focus the spectrum is in the plane of the energy selecting slit in the GIF. So if I insert the slit, the way that we do this is we have the slit inserted, and then we will basically sweep the slit over the field of view of the detector, and then we end up with this kind of isochromat or an isochromatic surface image at the edge. And the symmetry in this isochromat kind of gives you an indication of how well tuned or not the isochromaticity is. And that's pretty much everything. So obviously when you do tune GIF, all of that is automated, but I just wanted to give you kind of a breakdown of what's actually happening on the system when we hit that button. So it's kind of a black box for everyone. Okay, so I'll leave it there and we can move on to the next lesson.